Okay, so in this problem, the value of y is given to be 1 for x less than or equal to -1, and y is equal to x for x ranging from -1 to +1, and y is equal to 0.5 for x greater than 1. So if we plot that value of y for different values of x, we get this graph. So also it has been given that the probability density function of x is constant from -2 to +2. So we can see that since the area is 1, the magnitude has to be 1 by 4. Okay, so now to find the probability density function of y and the cumulative density function of y, we have to follow these steps. First of all, it can be seen that the value of y ranges from only -1 to +1. So the probability, the PDF, the probability density function of y for y greater than 1 and y less than 1 should be equal to 0. So let's take a look at that one by one. Now when y is less than -1, definitely fy of y, the probability density function of y, should be 0, because we can see here that there's no value for x for y less than -1. Also, when y is between -1 and 0.5, see, when y is between -1 and 0.5, fy of y is equal to fx of x, which we can see directly in this left graph. Also, when y is equal to 0.5, there are two things happening. First of all, this graph signifies the value of y is equal to x. So one element says that fy of y is equal to fx of x, and another element is actually this line for y is equal to 0.5. So the probability density function of y at 0.5 is nothing but the addition of these two elements, that is fx of 0.5, which is fx of x at 0.5, and an impulse which we will see here for y is equal to 0.5, and the area for that is 1 minus fx of 1. So next, for y between 0.5 and 1, this goes as normal in this line where x is equal to y. So since it has only a single root, we won't have two elements, just one element. Also, for y equal to 1, there are two elements. First of all, this straight line, and then this line. Now this line over here signifies an impulse with area CDF of x of -1, that is capital F of x of -1. So the probability density function of y at 1 is equal to fx PDF of x at 1 and CDF of x at -1. So now if we draw all that, we get this graph. So because of this x is equal to y line from -1 to +1, we get this uniform PDF of y, and there are two impulses which we found above, one at y is equal to 0.5 and one at y is equal to 1. And this impulse is 1 minus fx of 1, which is nothing but 1 minus 3 by 4. So the area is 1 by 4. It's written here 1 minus fx of 1, which is 1 by 4, and the area of the impulse at y is equal to 1 is nothing but again 1 by 4 fx of minus 1. So since this impulse is on top of this probability density function, we get 1 by 4 plus 1 by 4, which is nothing but 1 by 2 at these two impulses. Okay, so next, if we take a look at the CDF of y, it's pretty clear that from minus 1 to 0.5 it moves linearly with respect to x, where y is equal to x. But there's an impulse at y is equal to 0.5, which we have seen over here at y is equal to 0.5. So there's a jump of 0.25 there, and again from 0.5 to 0.1 there's a linear growth of y, because at that place the PDF was flowing linearly with respect to x. In other words, PDF of x is equal to PDF of y at that place. And again we saw an impulse at y is equal to 1, and the impulse area was 1 by 4. So again we see a jump of 0.25 there. So in short, this is the cumulative density function of y. Now it can be seen here. I have written it in equation form. So if we write fy of y can be written as 1 by 4 u of y plus 1 minus u of y minus 1, and thus two impulses at y is equal to 0.5 and y is equal to 1. Now let's take a look at how to find the expectation of y. Now since y only goes from minus 1 to plus 1, the expectation of y limits will go only from minus 1 to plus 1. So let's see what the result be. Now I've taken the 1 by 4 outside. We know that fy of y is nothing but 1 by 4, and these terms which I explained a while ago. Now if we put all of these things together and integrating it from minus 1 to plus 1, we get this equation. Now since this is an odd function, integrating it over an symmetric limits gives the value as 0. Now the only other two elements remaining are two impulses. So when we take an area of those impulses, we get 0.5 at this value and 1 at this value. This is nothing but the value of y at that particular place, and this 1 by 4 outside is nothing but the area. So finally, after multiplying 1 by 4 with the addition inside, we get 3 by 8. Thank you.